align, ignore, global, enable, / enable, economizer type parameters. Actually, I can remove economizer type. Doesn't really need to be there because it's on the economizer tab. Remove economizer type. Okay, so the default personality is packaged AC, 1 cooling, 1 heating, and here's those check boxes for the fan. And so if I look on the status tab, then I can see that the fan is on, and because when we're in the occupied state, the fan should always be on, regardless of the mode, cooling, heating, or deadband. If I wanted to see the fan turn off, I know from the fan tab or the configure tab, either one, that the fan should turn off in deadband for both unoccupied and night setback. I have the same independent cooling and heating set points for occupied, unoccupied, and night setback in this controller, where the unoff cooling and NSB cooling set points are 85 and the heating unoc and NSB set points are 65. So if I want to see the fan turn off on the status tab, I can use the state OR action button to override the state to either night setback or unoccupied. And so then the state has become overridden. It's now in night setback. It's still in the cooling mode. And to get out of the cooling mode, it needs to, the cooling and heating requirements both need to calculate down to 0%. And the zone temperature needs to satisfy the set points by 1 degree, meaning 1 degree higher than the heating set point, 1 degree lower than the cooling set point. So every 30 seconds, the heating and cooling requirements can update. So here at the next 30-second mark, went to 26. So probably need another, at least one more 30-second interval before that can go to 0. And then once this goes down to 0, then I should see it go into deadband. And actually on the fan tab, there's this fan start delay and the fan wait time. Those are both in seconds. Fan start delay says when I go occupied, how many seconds do I wait before I actually turn on? Fan wait time says when it's time to turn off, going into deadband for intermittent fan mode, how many seconds do I wait before I turn off? And so the fan start delay is there so that the fans don't all turn on at the same time. If you had like a, you could have like a peak demand charge if they all started at the same time. So you can see there that the fan did turn off after the 20-second wait. Actually, you could have seen it counting down. And then on the start, it'll count down as well. So the fan start time is so that they don't all turn on at the same time and give you a big peak demand. The fan wait time, I think, is just to let you, blow off every little last bit of heating or cooling off the coils before the fan actually turns off. And so now if I want to go back to occupied operation, I can go to the status tab, use the state OR action button to either restore state to daily event schedule, which means clear the override, or set state to occupied, which means override it to occupied. So I'll choose that set state to override to occupied. And so then after a short wait, then the fan should turn on because there's that fan wait time, which is here. So now the fan is back on and we're occupied. So we do the same sort of cooling calculation. Every 30 seconds, we compare the set points to the temperatures to the set points and update the cooling requirement when in the cooling mode, update the heating requirement when in the heating mode. So for cooling, there's this cooling tab, and there's some timing settings here that are all in seconds. The compressor duty cycle time, 600 seconds is 10 minutes. And so we'll turn on for a fraction of that duty cycle time based on the cooling requirement. So if we were at a 20% cooling requirement, then the compressor would run for 120 out of 600 seconds, similar to the way the electric heat runs in the VAV controller. But here we also have minimum on and off times, and that's to prevent the short cycling of the compressor. You know, we wouldn't want to turn it on for 8 seconds and then turn it off, or turn it off for 10 seconds and then immediately turn it back on. So the minimum on and off times take precedence over the calculated on time. So that means once it turns on, even if the calculation, like if we had a 10% cooling requirement, the calculation would say turn on for 60 out of 600 seconds. But since the minimum on time is 120 seconds, it would actually run for 120 seconds before it was allowed to turn off. Likewise, once it turns off, it's going to stay off for 180 seconds at a minimum, even if the calculation, the timing calculations were to say turn on, you know, more quickly than 180 seconds after you last turned off. So let's see, our controller right now, based on at least my controller, I've got a 53% cooling requirement. If I go to the cooling tab, I can see the calculated on time is 320 seconds. Since I have recently turned on, I can see the minimum on timer counting down from, it started at 120, it's counting down to 0. Happens to update every 4 seconds. And so the compressor wouldn't allow itself to turn off until the minimum off timer had counted down. And so this compressor duty cycle timer is in seconds. It counts up from 0 to the duty cycle time. So the compressor wants to be on for the first 400, in this case 524 seconds. We're only 124 seconds in, so it's still on. So what I'm going to do, I want to show you that it will transition to off. So I need to either adjust my temperature or my set point so that it stops rising so quickly. So I'm going to lower my temperature. If I go to, there's a setting called a zone sensor bias on other views input config. And here's the zone sensor bias in degrees. So I'm just going to lower my temperature by put in -1 to make it look like the temperature dropped by a degree. And then we'll see on the cooling tab how that affects the operation. So right now, at 100% cooling requirement, the compressor would be on indefinitely. So it doesn't turn off like very quickly once it gets to 600, it just stays on. But I'm going to gradually ramp my temperature down. I just want to show you that it will turn off at a certain time. And so there's now at 88%, it only wants to be on the first 524 seconds. We're only 188 seconds in, so it's still going to run for plenty of time. So I'm going to go back to my input config tab and lower my temperature by another degree. So I'm going to change my zone sensor bias from -1 to -2. You'll see that the zone temp drops. Takes a few cycles. We do a little bit of smoothing as we ramp down, but it will go down roughly a degree by the time it's done. And so I'll wait for the next 30-second mark, and it went to 73%, which if you did the math says to run for the first 432, I'm only 228 seconds in, so I still got another 3 minutes or so. I'm going to lower the temperature by another degree. Actually, I'll wait for this, my time. This controller apparently got reset without being synchronized because you can see the time is not right and the day of the week is not right. So what I can actually do is go to the configure tab, and there's a synchronize ASIC 1 button. And I'm only doing that because the time is not right. So if I click synchronize, then it'll take the time from my computer and push it into the controller once I click the synchronize button. There we go. And so let's see, yeah. So now I'm at 80%. So I'm going to lower the temperature by another degree. So my zone sensor bias on the input config tab was -2. I'll make it -3 to go another degree lower. Kind of slowly ramps its way down. See how the controller responds to that. And eventually, I just want to see that the duty cycle timer will count up past the calculated on time. That's the point when it turns off. So at the next 30-second mark, this will probably go down. Notice that we do also keep some compressor runtime statistics. let's see. So we're getting pretty close. I think I can probably leave it here. So the compressor started 1 time this hour, started 2 times today. It started 1 time since this controller had been programmed, which I think I just did recently. And then we keep track of the runtime today. And then what happens at the end of each day, we take the today values and update the totals. And then those are the new totals for the start of the day. So we're getting a little closer now. I want to run for the first 404 seconds, and it's 352 seconds in, so we're getting closer. And when the compressor duty cycle timer is higher than the calculated on time, then the compressor should turn off as long as we're not in a minimum on period. It's going up very slightly. I think it'll probably, I think maybe in the next minute or so it'll turn off, because the temperature is still higher than the set point, so the cooling requirement is ramping up slowly now, but probably not fast enough that I won't see the transition from on to off. So now we're at 70. Oh, you know, maybe I'll lower it ever so slightly. Maybe by half a degree, 0.2 of a degree, minus 3.2. I want to kind of see it happen naturally more than to the point where it just recalculates to be way lower. Okay, so actually we're going to get pretty close here. So 428 is the on. Now calculated 432, and then it's going to count up higher. Now it went off. Now we're in a minimum off period. So even when it starts back at when it counts up to 600 and starts back, we're actually going to not quite have satisfied the minimum off timer, I don't think. Yeah, so that actually show you that it will get held off briefly. And so while we're waiting for that, I'll talk about a couple other settings on here. So lockout cooling is a kind of a hard lockout. Maybe you do that in the winter time. Maybe you do that when the compressor's, out, been disabled because it's ready for service and there's parts on order. There's also a conditional lockout that we call OAT cooling lockout enable. So if you were to put a check in the box, then you could set the outside air cooling lockout set point in degrees. And if the outside air temperature is lower than the cooling lockout set point, then the cooling won't be allowed to start. And the outside air temperature can get to the controller in a couple of different ways. The simplest way is to wire an outside air sensor directly to input number 5, which is reserved for the outside air sensor. That's not really that practical when you have multiple controllers. You don't want to take the time and expense of the sensor to wire a different sensor to each controller, because they should all, the outside air is basically the same for all of them. So another way is to send the outside air value to the controller via communication. And there's actually a couple different ways to do that. You can either override input 5, which is reserved for the outside air input, or there's a way that you can make the outside air temperature basically a virtual point and not an input point. And then you can override the virtual point that is representing the outside air. And we still have a little bit of time to watch the compressor turn back on. So I'm going to just bring up a wiring diagram from the help documentation. So I'm going to do help ASIC 1, 8100. I think it's in the application bulletin. Let's see. AC. Yeah, there's a wiring layout here. And so this shows us the output wiring. And then there's an input list here that tells you kind of the default input assignment. So that's where I said input 5 was outside air. So here we're actually at a point where the duty cycle just started back from 0, but notice the compressor didn't turn on yet because we're still in a minimum off period. that minimum off period is about to count down, and then that allows the compressor to start. And so now it would want to be on for the first 500 seconds, and we just started, so it's got plenty of time to run. But I did want to show you a transition from on to off and then off back to on. And we happen to be able to see that the minimum off timer was keeping the output off for a few seconds. And so heating, there's a separate heating tab for the AC personalities. The settings have similar functions. They just happen to be shorter, as if this was kind of electric heat. And so these are the default base times. You can certainly change them, but we'll turn on for a fraction of the heat base time according to the heating requirement. And then we have minimum on and off times. We also have the same lockout options, a general lockout, unconditional lockout, or lockout based on outside air. In this case, if the outside air temperature is higher than the heating lockout set point, then the heating is disabled. And the heating is controlled by output number 4. So if we wanted to watch those transition from off to on, we can go to the heating tab, and then we would need to get our temperatures or set points in a position where the controller wants to heat. So I'll go to the status tab and see where we're at. So one way is to change the temperature with zone sensor bias. Another way is to change the set point. And so if I go to the configure tab, I can raise my heating set point to 75, which is higher than the zone temperature of 74. And then the cooling set point should be at least 2 degrees higher, so I'll set the cooling occupied set point to 77. So with heating occ temp SP of 75 and cooling occ temp SP of 77, here on the status tab, now I can watch. So it's got to get out of the cooling mode before it can go into deadband, and it's got to go into deadband before it can go into heating. So it might take a few cycles here, remembering that the calculation only updates every 30 seconds, so that's when the time equals, when the seconds equals 30, when the seconds equals 0. So that's not going that quickly. It's just sort of speed things up. I'm just actually going to reset the controller, because when we reset the controller, it always starts out in deadband. So if you go to the configure tab, there's a reset ASIC button that you can click on, and that's as if you had quickly cycled power to the controller. And so then always on reset, it'll reload the table to make sure it has the latest settings out of the controller. I'll go back to the status tab and confirm that it did start in deadband. So at the next 30-second mark, it should go into heating because my temperature is lower than the heating set point, and then we can watch the heating outputs turn on. So we should be in the heating mode now, and we are. Still 0%, but at the next 30-second mark, and I would expect the heating requirement to change, and then the heat will turn on for some fraction of the base time according to the heating requirement. So there's 2%. Actually, maybe that's not quite enough to get the heat on, because that doesn't calculate to something higher than 0. It's so low. So we'll need to get another 30 seconds before the heating on timer calculates. I guess in its mind, 120 times 2% is not high enough to register. So I think it's got to be at least 4 seconds before it turns on. Oh, we went down to 1%. So let me lower or raise my set point a little bit more. What do we got here? Let's go to the configure tab, and I'll raise it to 76 heating and 78. So on the configure tab, I changed the heating occ temp SP to 76 and the cooling occ temp SP to 78. And now switching over to the heating tab, the heating requirement, now it went to 7%. So that said, turn on for 8 seconds, but also make sure that once you turn on, you stay on for at least 20 seconds. So it's actually going to turn on for 20 seconds before it turns off. So there's the off, and then now once it turns off, it's going to stay off for at least 20 seconds. It's actually going to be longer. And so then once this heat-based timer resets back to 0 and counts up, then it will turn back on again. The minimum off timer will have been satisfied, so it should turn back on immediately once the heat-based timer counts back up to 120 and starts at 0. So back to the documentation, the wiring diagrams that are in the help guides. So this just kind of tells you the default assignment. So input 1 is zone temperature, input 2 is for the push button override, input 3 is for the set point adjustment if you have a slider. Input 4 is generally an auxiliary input. It actually gets used as a CO2 input if you are doing CO2 based control of your outside air damper. Input 5 is for outside air temp. Input 6 is discharge temp. Input 7 we can use as a fan digital input if needed. And then input 8 we can use as a mixed air temperature input for Economizer. We can also use that as an input if we have an occupancy sensor. And then on the output side, fan is relay 1. Then we have compressors 1 and 2 if they're being used. Then heat 1 and 2 if they're being used. Finally, compressors 3 and 4 if those are being used. So we're getting pretty close here. Heat-based timer counts to 116, counts to 120, starts back at 0. The heat should then turn on. And based on the heating requirement, it wants to be on for 44 seconds. And we're going to enforce the minimum on time of 20. So that shouldn't matter because it'll stay on for at least 44. So then it turned back on, and then we should be able to see a transition off here. The heating requirement doesn't ramp too quickly. So it wants to be on 44 seconds. We're only 24 seconds in. This will update soon. Now we want to be on for 52 seconds, and we're this many seconds in. So that might show us a transition before the requirement can update. So 48 seconds in, still on, 52 seconds in, still on, 50 seconds in, 56 seconds in, then it should turn off. And there's the off. And now it's enforcing that minimum off period. So that's the heating, switching on and off based on the calculations by looking at the heating requirement. Economizer, in the live class, usually we can simulate this a little bit better because we can adjust the outside air temperature and the mixed air temperature. It's kind of hard to do in the virtual environment, so I'm just going to talk about it. If you're going to choose the mixed air economizer option, then you would connect your mixed air sensor to input 8. If you're going to choose the discharge air economizer option, then the discharge sensor should be connected to input 6. That matches what we saw on this input list. Discharge on 6, mixed air on 8. If you want to see those choices for the economizer type, let's go to Other Views and Economizer. Shows this Economizer tab. And then the economizer type, top right, you can choose as mixed or discharge air. I think we do mixed air first. Yeah. So I'll choose mixed air. Click OK. Yes, I want to reset the device. And so there's some temperature settings in the upper left corner, which are relative to the outside air temperature. And the economizer in the 8100 doesn't have any humidity awareness. There's no enthalpy calculation or dew point or anything like that. So what it does is if the outside air temperature is higher than the econotemp SP, then we just go to the minimum position, which is a percentage because it's too hot outside. If it's between the low and the freeze limit, then we also limit the economizer to the minimum position because it's too cold. We don't want to bring in outside air that's too cold. And then if the outside air temperature is below the freeze limit in degrees, then we actually go to the closed position because that's really cold. So you can set those closed min and max positions in terms of percentage. And so that means the temperature range for the outside air when we can use that for free cooling is when it's lower than the econo temp SP, but higher than the econo low limit. And so then in the mixed air case, there's a mixed air temperature set point in degrees. Here's our mixed air temperature input value. And so there's this econo cooling requirement percentage, and it will go between min and max to try and meet the mixed air set point. So if the mixed air temperature is higher than the mixed air set point, the cooling requirement should increase. If the mixed air temperature is lower than the mixed air temperature set point, then the econo cooling required percentage should decrease, but it can go no higher than the max position and no lower than the min position. And that just runs a PI calculation by comparing the mixed air temperature input to the mixed air temperature set point. You do actually have some control over the PI calculation. We give you some, the P is the proportional constant, the I is the integral constant. I don't think most people change those. You generally shouldn't need to, but they're there if you want to see how they affect the calculation. And then there's Discharge Air Economizer is the other option. And so you can, even from the Mixed Air Economizer tab, if you change the economizer type here in the upper right corner to Discharge Air, then it'll actually change the tab to Discharge Air Economizer. Yes, you want to reset the device. And the screen itself looks very similar to the mixed air one. In fact, most of the stuff here on the left is identical. There's some differences on the right. We show you the discharge air temperature instead of the mixed air temperature input. There's a discharge air temperature set point instead of a mixed air set point. But the biggest difference really is this econo offset temp, which is in degrees, and this econo offset time, which is in seconds. And so under normal conditions, we go into the cooling mode. Outside air conditions are good. We start to open the economizer to meet the discharge air temperature set point. However, if the zone temperature exceeds the cooling set point by this econo offset temp in degrees for this econo offset time in seconds, while the cooling requirement's also at 100%, then that's a good indication that the outside air is not going to cool the space adequately. So then what we do is we go to a minimum position and we start mechanical cooling, and mechanical cooling takes over until we go back into deadband. And then the next time it goes into the cooling mode, it will try to use the economizer again. And that's because with discharge air, we don't really know if the temperature is dropping as a result of our economizer positioning or as a result of mechanical cooling. So in the discharge air economizer case, you can do economizer cooling or mechanical cooling, not both. With the mixed air economizer case, you can do both. And then the biggest downside to the mixed air economizers is the time and expense to install the mixed air sensor, especially if you're using an averaging sensor. Those can be fairly expensive. The duct sensors wouldn't give you as good a reading, but it would be a less expensive sensor. If you're choosing either of those economizer options, you can optionally choose the CO2 ventilation option. And so in ASI Expert, from the Other Views tab, there's a CO2 ventilation button here on the right side. And if you choose the CO2 option, then you can set the CO2 vent set point in parts per million. You'd configure input 4 to read CO2 in parts per million. And the ASIC 1 controllers are limited to a 0 to 5 volt range, so you'd have to make sure you had a CO2 sensor that had a 0 to 5 volt signal. I think a lot of them tend to be 0 to 10. Sometimes they're selectable between 0 to 5 or 0 to 10. The max position, I didn't point this out, I should have. Our default max position, for whatever reason, is not 100%. So normally you would set that max position to 100. And you can also set that same value here on the Economizer tab. And for CO2, we also have this vent max position, which is in percentage. And that's because if the CO2 levels were high on a 100-degree day or on a 0-degree day in terms of outside air, you might not want to go to 100% outside air because you might not be able to control the temperature very well if you're bringing in 100% outside air. So for the CO2 calculation, you can limit the maximum position that the CO2 calculation will calculate. And so then what the controller ends up doing is it says, okay, for temperature control purposes, what do I think my economizer position should be? And for CO2 purposes, what do I think my economizer position should be? And it'll just choose the greater of the two and use that to drive the analog output typically. And so go here. So that's what this describes. Input 4 is the CO2 input. The larger of the CO2 vent. This CO2 vent min position shows the CO2 calculation. The econo cooling required percent shows the final decision, which is the greater again of the temperature control and the CO2 control calculation. And then there's the mention about the CO2 vent position. There's two analog outputs on an 8100 controller. So on the analog outputs tab, you can assign the two analog outputs between cooling, heating, economizer, and changeover heating, cooling. Cooling, if you happen to have a chill water valve, that's a common case. Heating, if you had a hot water valve. Economizer, when you're choosing any of the economizer options, including CO2. And then the changeover one is if you had like a 2-pipe fan coil, then changeover essentially says follow the heating requirement when in the heating mode, follow the cooling requirement when in the cooling mode. And then there's a min-max voltage for each of the two analog outputs that you would set to match your actuator or whatever was being controlled by the analog out. So to see that, you can go to other views. Analog outs is here on the left. So if I had an economizer and analog output 1, I would choose the analog output 1 assignment as economizer. And then if it was a 2 to 10 volt actuator, I would set AO1 min voltage to 2, AO1 max voltage to 10. And then it would show me the output here in terms of DC voltage. So if you were to measure with your meter, that should be pretty close to what you'd see. And then you could repeat that for AO2 if you were using the second analog output for some different function. Or perhaps you have two actuators, maybe one for outside air, one for return air, and you're not paralleling them for whatever reason.